Hello, and welcome back to another video on math and science problems. Please make sure to like, share, subscribe, and comment if you have any questions, comments, or concerns about this video. Let's begin. For today's video, we will be talking about the FOIL method. Now, the FOIL method is used for algebraic equations to help simplify or to expand. Let's give an example. But before we get into that example, what is FOIL? Well, FOIL stands for F, which is first, the O, which is the next letter, stands for outer, the I stands for inner, and then the L stands for last. Make this more of an A. Okay, so FOIL method stands for FOIL, first, outer, inner, last. So let's give an example. So say we have a quadratic equation. The formula for the quadratic equation is a times x plus bx plus c. Now say we have 1, let's just make a equal 1, so we'll just have x squared plus, actually, yeah, plus 5x plus 6. Now, what we have right here is a quadratic equation. Now, if I were to simplify this, I would simply break it down into x plus 3 times x plus 2. And although this is not the lesson for the day, I got this through seeing what two numbers add up to 5 and what two numbers multiply to 6. So 3 plus 2 is equal to 5 and 3 times 2 is equal to 6. And they will both be positive in here because 3 plus 2 is equal to 5 and 3 times 2 is equal to 6. It won't be negative 3 or negative 2 because negative 3 plus negative 2 equal negative 5, which is not equal to positive 5. So that's why you have positive 3 and positive 2. Cool. Okay. So now you may be wondering, how will I go from x plus 3 times x plus 2? How will I take this back into this quadratic equation? Well, this is where the FOIL method comes into play. So, this is how we will do it. First, this is our first term. Let me put this in a different color. So, our first term is always going to be, let's do it in blue. So, our first term is always going to be this one right here. This is our first term. First gets distributed. So, the first goes to first. Then we'll do right. Then we go to outer. So first goes to the inner, first goes to the outer. Cool. Then we have our inner term. Inner goes to inner, and then inner goes to outer. So when we do this, take this back to black, we have the blue times x, so the blue shows us that it's x times x, and x times x is x squared. The x times 2 through the red line is plus 2x. The inner 3 times the x is 3x. 3 times x is 3x. And then the 3 times a 2 is 6. And then once we combine like terms, we get x squared plus 5x plus 6. So as we can see right here, we use the FOIL method to expand a quadratic equation. So right here, we had our x, and right here we had a 3. We took our first term, our x, and we distributed or multiplied it to the x plus 2 right here. So we took this blue line and we multiplied it times x times x. And we took this red line and multiplied x times 2. So that's how we get x squared and then 2x. Then we took our 3, our inner term, and we distributed that to the inner of this term, which is the x. 3 times x is 3x. And then we took the inner and we multiplied it by the last term, which is 2. So which is how we got 3x plus 6. And then once we combine like terms, x squared is by itself, 6 is by itself, but 2x and 3, since they both have an x, we will add them together, and that's how we get 5x. So this is a good example of how to use the FOIL method. This can be used for mostly anything to any degree of a quadratic. The degree is the exponent right here for the actually any constant or x variable. It depends. So any degree. So we can have a degree of 3. We can have a degree of 5, 6, 18, whatever it is, just whatever exponent that is leading. And we just want to break it down. So if we're ever given a broken down equation, we can use the FOIL method to get back to it. So if we have a difference of squares equation, say for example, put it in this corner, x squared minus 9, we know difference of squares have a positive and negative integer of the squared constant. So since the constant is 9, square root of 9 is 3. So we would have x plus 3 times x minus 3. And this is equal to that. So when we distribute this, let's put this in another color. Whoops. We have the x's, then we have the x minus 3, then we have the 3 in the x, and the 3 in the negative 3. There we go. Oops. Let's take this back. Cool. So we have x times x, which is x squared. Then we have x times negative 3, which is x negative 3, negative 3x. Then we have 3 times x, which is positive 3x. Then we have 3 times negative 3, which is 9, negative 9. So because we have negative 3 and positive 3, these cancel out. And this negative 9 is left, and this x squared is left, which is how we get x squared minus 9. Today's video was all about the FOIL method, first, outer, inner, last. I hope you enjoyed and learned a lot about the FOIL method. To give a recap, if you have a quadratic equation and you need to expand it, or you've broken it down, you have to expand it again. You're given something like this. It may even be three different subsets of an x plus something or x minus something, x minus 3, for example. Maybe you're given something like this. You'll do first, outer, inner, last. So you'll distribute the first term, then the outer term, then the inner term, then the last term. And once you multiply, and just for this example, we only did these two. This x minus 2 is not here. This was just a hypothetical example of how long it could be. We just did these two. So once we distribute those, first, outer, inner, last using the FOIL method, we're given this. We combine like terms, and then we're simply given back and put it back to the same quadratic equation that we were given, or we can find the quadratic equation from the broken down and factored subset. This can also be used for the difference of squares, such as x squared minus 9, x squared minus 4, and etc. I hope you enjoyed today's lesson on the FOIL method. Please make sure to like, share, subscribe, and comment if you have any questions, comments, or concerns about today's video, or any suggestions for videos you'd like to see in the future. This is Math and Science Problems, and thank you for watching, listening, and learning a lot about the FOIL method.